In 8.2.9, we're given two triangles. We could do this with quadrilaterals, we could do it with polygons, it doesn't matter what it is, but we're given side lengths, and we're told to discover what the missing side length is. Well, as you can see here, this triangle has a side length of 9, 24, and B. That's the missing length. Well, this triangle has a side of 3, A, and 5. Well, if I don't recognize this, it's one of those things that I need to look at corresponding sides with. So I know that 9 corresponds with the side of 3. If it's given that these are similar triangles, then there has to be a ratio that takes 9 to 3. Well, what I've taught in the past was simply stated, if you take where I finish, which is 3, and where I start, this is my beginning, and I reduce that, that becomes my ratio. So in this case, I'm looking to find this missing number right here, because this is where I ended, this is where I started, where I start, where I finish. So A should be 1/3 of this number right here. If that's the case, then A would equal 8. So now let's look at B. Well, B is going from this triangle to this triangle. So I start at 3 and I finish at 9. So my ratio is 3. So in other words, 3 times this side length gives me this side length. So 3 times 5 would be 15. So using ratios is how I determine missing side lengths. In this case, happened to be I used a ratio of 1/3. Big one, went from the bigger one to the smaller one, finding an angle in the small one. And when I went from the small one, trying to find the big angle in the big one, I used 3.